Alright guys, I wanted to give a quick lesson in terms of something that we call supernodes. And a supernode, when we're considering nodal analysis techniques, is anytime that we actually embed a voltage source in between two nodes. And that voltage source can have anything connected to it essentially in parallel, whether it's a 10 ohm resistor here or it could have a couple of other elements, doesn't matter. Essentially what we're doing is connecting that source in between two node voltages. So when we do that, that causes a really weird thing to happen within our analysis because we can't actually readily define a current that would actually go through this 2-volt supply right here. And so we actually have to analyze the circuit in kind of like this unique way that's really, really cool. And the thing with the supernode, though, is that we always have to satisfy KCL with it. And we're going to see what I mean by that when we look at basically two portions of how we would actually address this supernode within at least this example. But the one thing that we want to remember is that KCL has to be satisfied at that supernode like any other node. So current in is equal to current out. So in that case, the way we actually have to go ahead and start solving a system like this is we just go ahead and essentially in the first step kind of visually remove the 2-volt source and the 10 ohm resistor. And we're just going to assume, if we look right here, kind of remove that, and we're going to just treat this whole entire thing right here as just one big node. And we're going to satisfy KCL in that manner. So here, I define the currents I1 going into V1, and a current leaving out of V1 going through the 2 ohm resistor. And then V2, current I3 is leaving, going through the 4 ohm resistor, and then I4 is going to satisfy that 7 amp source. But again, I want to stress that the supernode, when we have that voltage source in between, we can't readily define that current through it. But we're going to, at first, treat it as if it's just one single node. Okay? So if we apply KCL, then I1 is equal to I2 plus I3 plus I4. If I expand that by the current voltage characteristics, we get 2 amps is equal to V1 minus 0 divided by 2 plus V2 minus 0 divided by 4 plus 7 amps. We go ahead and move that 7 amps over to the other side and we get negative 5 amps, and that's equal to 0.5 V1 plus 0.25 V2. Alright, some of you should be looking at that and going, well, if we treated everything like a supernode up here, and then treated it just as a single node, we have a problem. We got one equation and two unknowns. What do we do with that? Well, we can actually go ahead and rewrite basically V1 and V2 in terms of that voltage source by applying KVL. When we do that, we ignore everything else in the circuit except for V1, V2, as well as basically that voltage source. So, and I'm just going to maneuver this right here so we have both in line. So if we look at the second right here, I kind of removed everything within the circuit except including that 10 ohm resistor, in which we actually have V1 and V2, which we know exist as a potential difference that's going to be from that node to ground and also V2 to ground. And then here we got that 2-volt source. So if we apply KVL, we can see that V1 plus V2 plus 2 volts is equal to V2. Voltage rise, voltage drop. And if we rewrite that equation in terms of V1 and V2, we get 2 volts is equal to negative V2 plus negative V1 plus V2. So that gives us our second simultaneous equation. If we did substitution or put it into a matrix, we would find that we come up with V1 is equal to negative 7.33 volts and V2 is equal to negative 5.33 volts. So Either way, in bigger circuits, it doesn't matter how many different node voltages that we have. If we ever had a supernode in there, we would be able to basically treat that supernode as if it's just a regular node and then apply KCL to it, but then rewrite the node voltages in terms of that voltage source that's in between those two nodes. And note, however, that in our calculations, that 10 ohm resistor that was connected in parallel to this doesn't even come into play, and that's because in between those two nodes we've already defined that voltage between V1 and V2. In this case, it's 2 volts. So we're going to see a couple of practice problems as we go through additional lectures, and we're going to come back to this. But I wanted to give kind of like a speed lesson in terms of how to deal with supernodes. You'll see it in the book, probably see it later on, further down in terms of electrical engineering classes. And we'll be coming back to this, but I wanted to give a quick introduction. See you soon.